Here we're going to try example 3 from chapter 29. In this example, and very similar to example 2, it's given us a few constraints. We graph it and find the feasible region. But I want you to notice the big difference here is everything is going to be greater than. So that's going to change how the constraints look. And then we have our x is greater than 0, y is greater than 0, greater than or equal to. So that's our first two constraints. And those are pretty common in these questions to be the first two. And I'm going to do these in red this time. So there's x is greater than 0, greater than or equal to 0. So that's my x equals 0 line. And here's my y equals 0 line. Here. And we know that everything's going to be above that, go in this direction and this direction. So that's the first two pieces of information. I had to rewrite one of the equations. You can see it started here, or inequalities, but I rewrote it. So now we get x plus 4y is greater than or equal to 12. Well, if x is 0, y is going to be 3. Gives me a point right there. But if y is 0, x is going to be 12, right here. By using the intercepts, connect the dots, and I get this. So that's that line. This line, x plus 4y equals 12. X plus y equals 6 is the next one. So when x is 0, y is 6. When y is 0, x is 6. Textbook doesn't really show any of the algebra for this, and I'm not going to either, because by this point I'm hoping you guys are getting a fairly good understanding of this. There's that. So there's that graph, and this line is x plus y equals 6. So now we have this last one, 5x plus y is greater than or equal to 10. So when x is 0, y is 10, gives it way up here. And then when y is 0, 5x equals 10. So that means x is 2. And connect the dots on that. Look at this. Now, I always do my shading in pencil for some reason, but now it's everything above the lines. So that means my feasible region, or simplex, whichever term you prefer to use, is going to be above the lines. So everything above those lines, and out here it's going to be above y equals 0 and above x equals 0. So it's creating that little space. Now my vertices are going to be here. So that's 12 and 0. And then I have a vertice here. 4 and 2. And then here, 1 and 5. And then lastly up here at 0, 10. So those become our vertices for this particular question. You can think of the vertices as the corners or the points of intersection on the different constraints. And that's it for that one.